Right, so in this video we're going to solve problem number 68. What it says is that there is a spring that is attached to a block of mass capital M lying on some surface, and now first thing you do is you place a mass M on the spring, so capital M, and what this does is it compresses the spring by an amount mg over k. Now you further compress this mass, so now the mass M is here, the spring is here, and you compress it by an amount of 3 mg over k, so the total compression is 4 times mg over k. And what it says is, so you let go of the mass at this point, so it's at rest, you let go of the mass, and this mass is going to fly up, and it says what should be the largest, what is the largest value of capital M that would lose contact with the surface. So what we're going to do is, in order to find this, the largest value of M, we need to find by how much the spring extends, because that would be the force that the spring would exert on the block M. And in order to find the spring extension, what we need to do is use mechanical energy conservation theorem and find out, at the when this block lowercase m stops, when this stops, okay, what is the total extension of the spring. Alright, so let's measure all distances from this red line here, okay, and oops, where's the red line? Yeah, here's the red line. So let's measure everything from the red line, and we're going to do, what we're going to use is use MEI equals MEF. Now MEI for the block is, its potential energy is 0, but the spring has, and it's not moving, so that energy is 0, but the spring has potential energy. It is 1/2 k times 4 mg divided by k squared. That's the total energy, mechanical energy in the beginning. And at the end, the block is again not moving, but it has gravitational potential energy, which is equal to m times the total amount. And what we'll do is we'll call the amount from the equilibrium position x, so its distance is going to be x plus 4 mg over k plus 1/2 times k times x squared, which is the spring potential energy. Great. Now all we need to do is solve for x and then find the force. So let's proceed. So what we're going to get is, we're going to have 1/2 times k times 16 m squared g squared over k squared equals mx plus 4 m squared. Oh, wait a minute, there's a g missing, so it's 4 mgx plus 4 m squared g squared over k plus 1/2 times kx squared. Now I can simplify this and write this as 8 m squared g squared over k equals mgx plus 4 m squared g squared over k plus 1/2 k times x squared. Great. So now if you see, I can move the 8 m squared g squared on the other side, and I rewrite this as 0 equals mgx minus 4 m squared g squared over k plus 1/2 k x squared. Now I'm going to multiply everything by 2, rearrange the terms so that I have my quadratic term first, so I get k times x squared minus 4, sorry, not 4, that's going to be our third term, minus 2 mgx, or rather plus 2 mgx, and then minus 8 m squared g squared over k equal to 0. There's one more thing we'll do at this stage. We'll divide everything by by k. So I get x squared plus 2 mg over k times x minus 8 m squared g squared over k squared equal to 0. Alright, so we're very close to the answer now. So at this point what we can do is we can we can find the roots by doing a regular quadratic equation, or we can see that this can actually be factored into the following. We can write this as x squared plus 4 mg over kx minus 2 mg over k minus 8 m squared g squared over k squared equal to 0. Now I can factor the x out, so I get x times x plus 4 mg over k minus 2 mg over k times 1 no, there's an x missing here, so x minus or x plus 4 mg over k equal to 0. And at this point we can factor this as x minus 2 mg over k times x plus 4 mg over k equal to 0. And now my terms are x equals 2 mg over k or x equals negative 4 mg over k. Now we don't care about the negative value, all we'll do is we'll use the positive one. So this now tells me that the force that the spring exerts is equal to k times 2 mg over k, which is equal to twice mg, and this is the force that is going to lift the object, and this tells us that the object's mass m, the maximum value it can have, is going to be 2m. Alright, hope that helps.